Topic is linear equation, rational coefficients, which is just big words for fractions. We get to solve. Example 1. Our first equation, I've got 1/3 x minus 1/6 y equals 13. In the second equation, I've got 3/4 x minus 1/8 y equals 8. So we have to get rid of, well, who here likes to work with fractions? And for the people watching the video, nobody put their hands up. So we have to get rid of the fractions. So how do we get rid of the fractions? If you're thinking of switching to decimals, that's not the right thing.
Maybe you would times them together and then
Times together how? Like, yep.
so like 1 over 3x to 1 or -1/6y. Would you times those two?
Oh no, we can't, because what's the sign in between them? What's the sign in between those two terms? Yes. So then, if there was a times sign or something, we could. Darren.
Would you try to make the fractions into whole numbers?
How? Yes.
You would times them by the numerator?
That's so warm. Not by the numerator, but by
The denominator.
Yep. We'll add a little bit to that. Multiply each term by the lowest common denominator. Clean that up a little bit. Multiply each term by the lowest common denominator. And each fraction, each little equation will have a different lowest common denominator. For example, for equation 1, what is the lowest common denominator?
3.
Oh,
6.
it's 6, because it's that whole thing. If we make a list, kind of like 3, 6, 9, 12, 15, and then 6. Oh, that's the first one that matches, so that's the lowest one.
Oh, that's how it works.
Yes, and you know what? If you can't think of the lowest one, if you just take them and times them, it's going to work too. You'll be working with bigger numbers, but it works. So that works. But 6 we got told, so we multiply each term by 6. Remember, everybody gets a card. Every term, even the term after the equal sign that isn't a fraction, gets multiplied. Okay, so I'm just going to move the work down a little bit here and go after what I wrote. So it's that whole thing where, how many times does 3 go into 6? Yes. Add 6 into 6? Yes, that is an appropriate one finger there, yeah. And then we just have the times. What's 6 times 13?
78.
Yes. And now for the next one. 3/4 x minus 1/8 y equals 8. Lowest common denominator, 8. 8. Yeah. Sorry, Darren. Darren got it before you. But, and again, if you can't think of it, you could go 4 times 8, which is 32, and work with that, and it's just bigger numbers, and it works just fine. Middle Darren, since you did a good job in the last one, what's going to happen here?
My name's Justin.
Justin?
Yes.
Okay, Mr. Timberlake, 4 goes into 8 how many times?
2 times.
So then this would become what?
Oh, I look like here. 6.
Yes.
Three sides. One. Y.
Yeah, and 8 times 8.
One equals one. Oh,
Eight.
equals-
8 times 8.
Oh,
Multiply.
64.
There we go. But, questions to hear? I think that's the hard part of the question because now we have to decide. You get to decide if we're doing substitution or elimination. So we look at it and make a decision. What will you decide? Exactly. Welcome back to the show.
Yeah.
And honestly, there's no wrong decision. You just have to decide, I'm going to do this, and then you do it.
2y minus 1y equals.
Well, what about it? Are we doing substitution or elimination?
Elimination.
Okay. Okay, so let's do, they're doing elimination. Let's stack them up.
Oops.
But our signs are the same in the middle, so what do we have to do to the one equation there?
Times it by positive.
Will that change anything? We change times it by positive.
No. Negative.
Negative,
1.
exactly, times it by a negative 1. So then we get what? So of course the top equation is not going to change. But the bottom one will become
Negative 6x, positive 1y, and a negative 64.
absolutely. So the whole idea with elimination, of course, we're going to add them up so they eliminate, and those eliminate. I love it when that happens. So nobody ever. So those eliminate, and we'll get left with what?
Negative 4x.
Bruh.
Exactly.
And 14.
And then,
Divide by negative 4.
yep. And x is equal to. We can do decimals here. And you know that I am a big fractions guy, but this is we can do decimals.
3.5.
Okay, any questions?
Negative 3.5.
I was going to just not do anything in this. We'll find it in the check. But yes, don't drop the sign. Good. So x equals 3.5. The thing I like with this question, it's not a whole number. That's okay. It's a nice, this is what I call a nice decimal. You get something that's 3.42681. Okay, there's something wrong. Okay, but that's just x. Now what? Back in the corner, Darren, what would you do from there? Because I want you to keep going. So if you couldn't hear, he said why, and I tried to make a joke. Anyways, yes, you're correct. Keep going.
2 times negative 3x minus 1y equals 78.
2 times negative 3.5 minus y equals 78, okay?
Times 2 by negative 3.5.
Which is
Negative 7.
sure is.
Then you add the 7 over.
Yep.
Negative 1y equals 85.
Okay.
Divide by negative 1.
Yes.
Y equals negative 8.
Yes. Awesome. Questions from there? Yes.
Can you scroll up?
Yep.
Please?
Yep.
Just for a little bit.
Yep. Absolutely. I got it. Now what? Sure. sir.
Now you would take, now you would take 6x minus 1y equals 64 and put the x and the y in.
Yeah, do the check with that equation, absolutely. Check with the other equation, because if we made a mistake in the last one, if we use the last one, chances are we won't find it. Well, you guys might, but I'm just talking about the history of what kids have been doing. So I'll fill it in. You can tell me what to do from there, please.
D negative 21 minus, plus 85 equals 64.
Yep.
And negative 21 plus 85 equals 64.
Oh, gotta like it when that happens. Good. What's left, Logan?
On order, so it would be 3.5 and negative 85.
It'd be what?
Negative 3.5 and negative 85.
There we go. I just didn't hear the negative on the first one. That's exactly it. Good. So after we get rid of the fractions, it's exactly like we've done before. So, yeah. That was the first one. So that was a fractions one. Another one you get asked is decimals. You knew it? Okay, here we go. Again, solve, of course, what else would it be? First equation, 0.08x plus 0.07y equals 1,220. And the other equation is 0.06x minus 0.05y equals 300. Yep. That's what it is. So in the same way that we multiply to get rid of fractions, we're going to multiply to get rid of decimals. That's all about shifting the decimal. So what can we multiply so we could shift the decimal so we won't have a decimal in the equation anymore? Sure. Okay. That sounds good. Multiply each term by 100. Does that work on just that equation or on both? Oh, well, then you'd have to think of something different for this one. Okay. So what are we going to get by moving the decimal over like that?
Get 8x plus 7 equals 122.
Yeah. And the other equation?
6x minus 5y.
Yeah.
Equals 30,000.
It does. Okay, awesome. Okay, again, we need to make a decision. What are we going to do? What are we going to do? You get to pick this time.
Well, neither are really I guess we can do elimination.
Okay, and I think which variable? Yeah, because it's got a positive and a negative. That's an excellent idea. Love it. So elimination. So what are we going to have to do so we can eliminate? Each equation.
So you
Oh, me?
Sure, your idea. Yeah, we're gonna make this one by and that one by.
5 and 7.
Yes. Yes, yes, yes. 5 and 7. Again, so go over here. What will our new numbers be?
40x plus 45y.
Mm-hmm.
Equals, okay.
Well, I can do the zeros for you. 0, 0, 0.
Uh, 610
1,000. Yeah.
And then it'll be 42x.
Mm-hmm. Oops, not plus, minus.
35y
Yep.
equals 150.
What's 7 times 3? Oh, look at your calculator. What's 7 times 3?
21.
Yeah, and then 4 zeros. There we go. There we go. Love it. Positive and a negative, add them up, they're just going to go away. So if we just add up, what are we going to get here?
82x.
Yep, equals.
820.
Yep, 820,000. That's exactly it. And again, I do have a good feeling about this. So then we just have to. Yep. Yeah. Absolutely. X equals 10,000. Okay. Now what? Oh, I don't know. Who I'm going to talk to. So we're going to do something risky here, but if we do something wrong, it'll come out in the check. I've got 10,000 here, and we want to solve for y, right? So where should we put this x into? I've talked to you recently. Yeah, so you get to pick. Top or bottom? Okay, sure. Oh, bottom, okay, fine, fine. So 6 times 10,000 minus 5y equals 30,000. Okay, now I'll let you do the rest. Yeah, for sure.
That would be 60,000 minus 5y equals 30,000.
Yes.
And then you'd subtract the 60,000 from plus seconds.
Yes. Minus 5y is going to equal.
Negative 30,000.
Yep, you got it. And then
Divided
I.
by 5.
That's better. What's 30 divided by 5?
6.
What kind of a 6? Oh, no, it's 2 negative, so it's going to be, oh, yeah. So 6, so that went into 30, so how many zeros are left over?
3.
Yep. Exactly it. That is exactly it. I didn't like my zeros there. Yep, 6,000. Good. So that's all fine and good, but the next part, you really need to use an original equation for the next part. Because we made a mistake about any of this multiplying. even though we got a good, I got a good feeling about it, because our numbers are coming out nice. My glasses aren't getting heavy. We should use an original equation. So on the side there, which equation should we use? White bunny hug girl. Is it that equation or that equation? The first one? Okay. Okay, so. .08, 10,000 plus 0.07, 6,000 equals 1220. Oh, I squeezed it in. So let's put 0.08 times 10,000. Yep. And what is 0.07 times 6,000? What is 800 plus 420? Perfect. Awesome. So, our check worked out good. Logan?
The order pair is 10,000 and 6,000.
Well, he should be. It's his thing now. Yes, in the order pair. Questions to hear? Because these are basically the two types that you're going to get in fractions or decimals. Yeah.
How come, wait, are we able to just check the other way without the decimals?
What if you made a mistake
I did them both.
with the other one? You won't find it because you used those there. So I really want you to go with the original one, because if you made a mistake with the multiplication, if you use that mistake multiplication equation, you won't find your mistake. So that's why I really want you to not do that. Other questions? Good question. Okay, in your textbook, start it off. Page 426, 19AB, and page 438, 12BCD.
Perfect.
Perfect.